All right. So you just finished number 3. You should have checked your answer. You're going to get fractions, of course. Now, here's the tricky part, because it's going to take a lot of courage. You're going to have to guess. You're going to have to check. You're going to have to be wrong a lot. And you're going to need to remember some patterns, which we'll talk about in class. So for 8-1 part 2, we are going to start describing patterns. Like, what pattern do we see and what formula can we put behind it? Okay? We're on page 411, and we're going to do number 4 first, okay? This is not easy. So, number 4 on page 411, 3, 5, 7, 9s, comma, dot, dot, dot. Describe the pattern. Write the next term. Graph the first 5 terms, and then write a rule for the nth term in the sequence. Alright, so I actually want to start with the rule first. So describing the pattern, I can see these are odd numbers, right? We're starting with 3, not 1 for some reason, no idea. So let's see if we can come up with a rule. To do that, I try to stay organized. I make a sideways chart. I'm going to write 3, 5, 7, 9, okay, so this is my A sub n, okay, and then here's my n. Now I need to figure out what's in between. The best thing that I can do is at least identify that the first term is 3, the second term is 5, again, remember, the language is important, the third term is 7, the fourth term is 9. So the question I want to ask myself is, how do I go from a 1 to a 3, a 2 to a 5, a 3 to a 7, and a 4 to a 9? How do I turn 1 into 3, 2 into 5, 3 into 7, right? And so on. And what's the pattern, and what will work every single time for each of them? So I can think to myself, well, if I multiply 1 by 2, I get 2. 2 times 2 is 4. 3 times 2 is 6. 4 times 2 is 8. And those aren't these numbers, but 1 times 2 is 2, plus 1 is 3. 2 times 2 is 4, plus 1 is 5. 3 times 2 is 6, 6 plus 1 is 7. 4 times 2 is 8, 8 plus 1 is 9. So my rule is A sub n is 2n plus 1. How did I get that? Practice. That means I was wrong a lot more times than I was right, and you're going to have to do the same thing. So here is a rule. So we described the pattern. Oh, let's write the next term. We know the next term. So A sub 5, because 4 was the last term they gave us, is 11. 2 times 5 is 10. 10 plus 1 is 11. All right, now we want to graph the first 5 terms. So I do want you to make a quick sketch. We only need the quadrant 1. It looks like we can count by 1s down here. We're graphing the first 5 terms. And let's count by 2s over here. So I have a point at 1, 3. 2, 5, 3, 7, 4, 9, and 5, 11. So here are my first 5 terms. We are not connecting the dots, but we should notice that it looks like a line, which in fact it is in y equals mx plus b form. All right, so we described the pattern, we found the next term, we graphed the first 5 terms, and then we wrote a rule, which is an equation, for the next sequence. Okay, let's see if we can do number 5. Number 5 on page 311 is 3, 8, 15, 24, dot, dot, dot. And what do these look like to me? They look like a bunch of numbers on a page. Not really quite sure what to do to describe them, so the words will come later. Let's see, can I think of the next term? Not really. So let's at least write a rule. Here I'm going to have n. Here I'm going to have a sub n. So they give me 3, they give me 8, they give me 15, they give me 24. Oh, I need to figure that one out. But 3 is my first term, so I need to be able to turn a 1 into a 3. 2 is my second term, I need to be able to turn a 2 into an 8. 3 is my third term, I need to be able to turn a 3 into a 15. 4, I need to be able to turn into 24. And then I got to figure out what my fifth term is. So looking at it right now, let's see. I can think of, well, it's obviously not 1 times 3, that's 3. 2 times 3 is 6, so that doesn't work. I can't just say, oh, a sub n is equal to 3n, right? 3 times 1 is 3. Yay! 2 times 3 is 6. Boo! I can't do that. So that doesn't work. Let's try, what about a sub n is n squared? So 1 squared is 1. Nope, that doesn't work. 2 squared is 4. Nope. 3 squared. Okay, so that doesn't work. But I noticed that 3 squared is 9. 4 squared is 15. 5 squared is 25. 2 squared is 4. I don't know why I skipped that. So this one squared is this, minus 1. This one squared is this, but then take away 1. This one squared, take away 1, is this. That's a better way to say it. 5 squared is 25, but take away 1, I get to the number before me. So, like, what if I took my n, the number that I'm on, and I added 1 to it? So 1 plus 1 is 2. 2 squared is 4. And then I take away 1. Let's see if that works. So 1 plus 1 is 2. 2 squared is 4. Take away 1 is 3. 2 plus 1 is 3. 3 squared is 9. Take away 1, it's 8. 3 plus 1 is 4. 4 squared is 16. Take away 1, I get 15. 4 plus 1 is 5. 5 squared is 25. Take away 1, I get 24. So this actually works. And I'm kind of shocked because that was a lot of brain power. So can I get the next number? A sub 5 is going to be 5 plus 1 squared, take away 1. 5 plus 1 is 6. 6 squared is 36. Take away 1, 35. So I'm going to write down, I'm going to write down that a sub 5 is 35. Okay, so I have a rule. I have the fifth term. Did I describe the pattern in words? Add 1, square it, then take away 1. That could work. You might find a different way of doing it. There's actually a different answer in the book. Write the next term, graph the first 5 terms. Alrighty, so quick graph. We're only in the first quadrant, it looks like. So I'm not going to bother with anything else. And I'm going to count by 5s because I have to get myself up to 35. Okay, so we have 1 comma 3, 2 comma 8, 3 comma 15, 4 comma 24, and then 5 comma 35. We're not connecting the dots, but if we think about it, oops, that does not exist. If we think about it, it looks like a parabola. right? Which of course it should, because we have this equation right here. Sorry. I'll give you a chance to copy it down, check your work rather. You don't need to copy it. Should be working along. All right. Now, this is going to be tough, and you're probably going to hate it, but that's the whole point. You need to really try it. You need to do numbers 6 and 7, all right? You might not be able to come up with a pattern at all, but if you don't try, you will never see the rule that you need to apply for number 6 every time you see it, okay? And number 7, I think, is kind of like number 5, where it's just I randomly decided to square numbers, okay? I was just trying things off the top of my head. Number 7, I think, is kind of like that. I don't know if it's squaring. I don't know what it is because I haven't tried it yet, but you're going to try it, and then we're going to talk about it in class tomorrow, okay? That is it, besides a lot of practice for the first 2 sections of Chapter 8, Section 1.